black holes can also eat, so to speak. So what happens is this. As we're talking about this material right here, that this black hole sort of has an event horizon, but it also has things in a happy orbit. So we could say that, stars and gas and dust, all that sort of stuff, they can, we say they accrete. So they can accrete around a black hole. And what we mean by that is that, let's say I draw my black hole. Let's say I draw it as a black dot. That's my black hole. Now what we're going to do then is we're going to have, dust and stars and things like that all sort of going around this black hole here. Okay, so let's say they're all rotating around. This could be like the dust here and the gas. It's mainly gas here. As it goes around in a circle, well, some of it may actually sort of, because they interact with each other, maybe there's some drag and they slow down, and that means that they sort of spiral inwards. Well, they slow down in a rotational sense. They'll actually sort of spiral inwards, and eventually they cross this event horizon and go into the black hole. Turns out through conservation of angular momentum, it predicts that this material, if it goes sort of inside, means that something has to go out. And it turns out we have these big jets of really, really high-powered, extremely high-energy light. This is actually some of the most powerful things we know of in the universe are when these black holes are eating. So what they do then is they make what we call an AGN, which is an active galactic nucleus. Now remember, nucleus means center. So what that means is if you see a galaxy and its center of that galaxy is active, in other words, if it's giving off this super high energy light, then we call it an AGN. And this is really interesting stuff. These are some of the most powerful things or most energetic things we know of in the universe. We have certain galaxies, depending on sort of how they're lined up with us and some of these definitions. We call some of them Seyfert galaxies. We have other names for them too. They could be called quasars. That's another name for them. There's even some called blazars. So it's really interesting stuff. So this is worth looking up. So these can be really useful though, because if they're lined up with us, where we're, if we're up here and we're looking at this light, see if it's lined up with us, then we can see them. If they're really intense, we can see this light when it's really far away. So some of our most distant objects we can detect are these. That's because the regular stars don't give off enough light given their distance for us to be able to detect them. But if they're really bright, we can see bright things really far away. So black holes can eat. And as well, black holes can be extremely massive. Remember we looked at the black hole at the center of our own Milky Way galaxy? It was around, the black hole had a mass of around 4.1 million solar masses. That was the one at the center of the Milky Way. Well, it turns out there's another one called M87. It's a ridiculously huge galaxy. This one, this is M87. So it has a size of around 500,000 light years in size. So that is really, really large. It has a distance of around, and this is around 53 million light years away. But what's interesting is this, that the black hole at the center of M87, that one's been estimated to have a mass of around 2 billion solar masses. Okay, so this is actually pretty crazy. So somehow we think it must have merged, maybe a whole bunch of galaxies merged together, so it sort of ate up all the different black holes in the center of all the other galaxies. It sort of ate, and it became this big giant blob, this huge mess. That's around 2 billion solar masses is the mass of the black hole at the center of this baby here. And here's a picture, and this is still galaxy M87. And so we're actually seeing, within this picture, I know it looks like this is just the center and then there's no more galaxy, but it turns out no, the galaxy is way, way big. It's huge. These dots you see are usually stars in the foreground, so try to ignore those. But this is something very, very massive. It turns out these little pixels, those are lots and lots and lots of stars. They're just really far away. So this thing is so big, but it turns out it's an active galactic nucleus. In other words, it's got this jet effect coming out. And through special filters, they're able to actually see this jet coming out. This jet is huge. This jet right here. Okay, this is a jet of, these are really, really energetic particles. These are like electrons and subatomic particles that are being accelerated to nearly the speed of light. And so you have this really, really bright light happening here. And this jet, it's crazy long. It's around 5,000 light years long here. So this is really, really long, this jet. And so this is an example of an active galactic nucleus. So black holes are really interesting. Like I said, they're very strange, first of all. They're at the center of most galaxies, including our own. Some galaxies have multiple black holes. We now think that galaxies and black holes sort of form together, or, well, they're certainly related. They're certainly sort of friends with each other somehow. And, of course, we can then see that things don't all get sucked in. Things can go in orbit as long as you stay away from this one sort of Schwarzschild radius here. Turns out they can eat and burp and then fire out these huge jets of gas, which is what we see in galaxy M87. I think this is really, really interesting stuff. This is right at the forefront of physics. This is right where our understanding of physics is sort of murky. We're still trying to figure this stuff out. So there's a lot of room for people like you to be learning about galaxies and black holes and try to figure out what goes on in the universe around us.